Hello. Oh, so in this lecture, I'm going to discuss about the SR flip-flop, which is also known as set reset flip-flop. Okay, so in SR flip-flop, two inputs are there. One of the input is known as S, other input is R, and two outputs are there. One is known as QN, the other one is the inverted version of the remaining one. Okay. So S and R, two inputs are there, and Qn and its complement will be there as its output. So two input, two output. And other than that, as it is a flip-flop, clock will be by default, it will be there. Okay. So this is some sort of block diagram representation of SR flip-flop. SR flip-flop. But inside this block, what are the components are there? These components are there. So these components are existing inside this block. Okay, what are the things? 4 NAND gates will be there and some connections will be there, proper connections will be there to implement this SR flip-flop. Okay, now how SR flip-flop works? In order to understand the principle of SR flip-flop, you need to first write down the truth table of a NAND gate, because in SR flip-flop it is nothing but the combination of some NAND gate. So if you understand the concept of NAND gate, then you can easily understand the principle of SR flip-flop. Okay, so write down. Suppose A and B are the two inputs of the NAND gate and Y is the output. So 0, 0, 0, 1, 1, 0, 1, 1. Okay. So A and B are the inputs and Y is the output for the NAND gate. So 0, 0 means for NAND gate, what output you will get? This is 1. For 0, 1, 1, 1, 0, 1, 1, 1, 0. So from this truth table, what you have understood? It means that if one input is 0, then output will be 1. That we have understood from this truth table. This is a principle of NAND gate. If one of the input is 0, then you can see by default the output is coming 1. And when the output will be 0, if both the inputs are 1, then only the output will be 0. In case of two input NAND gate. Okay. Now this thing you have to understand, and this line is very much important to understand the concept of SR flip-flop. Okay. So in SR flip-flop, what are the things are available? You have input S, you have input R, you have clock input, you have this QN output, and QN bar is the inverted version of that thing. And from there you need to identify QN plus 1 and QN plus 1 bar. Okay. Now, so try to understand the principle of SR flip-flop. So SR clock, and we need to find out QN plus 1. So SR means how many combinations are there? 4 combination 0, 0, 0, 1, 1, 0, 1, 1. And every time we are considering the clock. What is Qn plus 1? After applying the clock, what output you are getting in Qn terminal, that will be known as Qn plus 1. Okay. If Qn is your present output, after applying the clock, what output you are getting in this terminal, that will be known as Qn plus 1. Okay. And same thing is applicable for the inverted terminal. Okay. Now, take the first condition. Suppose S equal to 0. So let me write down S equal to 0 and R equal to 0. First combination we are considering. Okay. Now as S equal to 0, R equal to 0, and clock by default it is 1. I already told clock you need to consider every time you need to consider clock equal to 1. So this arrow means we are considering clock terminal equal to 1. Now check this truth table. What we have observed, if one of the input is 0, then output will be 1. So you see this red color. So let me give some name. This we can consider as NAND gate number 1. This number 1 gate. This we can consider 2, 3. This we can consider AND gate number 4. So that if I give the numbering, then it will be easy for you to understand. Now in 1 number NAND gate and 2 number NAND gate, what inputs are applied? S equal to 0, R equal to 0. So both at least one of the input is 0. So what you have seen, if at least one of the input is 0, then by default the output of the NAND gate will be nothing but this will be 1 only. So this is 1. This is also 1. Okay. Now for the NAND gate number 3 and 4, what it is happening that now we need to identify. So you see in 3, whatever the other terminal means, what other input is applied in the uh, other terminal of 3. You see this is nothing but Q bar only it is applied. Q bar only it is applied to the other terminal of 3, NAND gate number 3. And here 1 is applied. So what does it mean? What output will get? According to the principle of NAND gate, Qn bar into 1 and it is whole bar. This is the principle of NAND gate. What is the expression for NAND gate? All of you know. If A and B are the inputs of NAND gate, then the output is given as A dot B whole bar. So same thing only applied. Here you have Q bar, the other terminal is 1 and whole bar. So what does it mean? Q n bar into 1, that is Q n bar, and whole bar is. So bar will be cancelled out. Ultimately, you are getting Qn. Okay. So what does it mean? If you have applied 0, 0, then you are getting the same thing only. It means no change. You can write some remark. Okay. So whatever Qn previous output is there, that only you are getting in the Qn plus 1. Same thing only. So it means that in SR flip-flop, if you put S equal to 0, R equal to 0, then the next output will be exactly same as previous output. Okay. Now come to the next condition. Next condition is, consider the next case, S equal to 0, R equal to 1. And clock by default, I already told, clock you need to consider by default 1. Okay. Now see, as I told, if one of the input is 0 of an AND gate, by default, the output will be 1. It means that here you will be getting the output of 1. And in the other NAND gate, means NAND gate number 2, what input you have applied? You have applied the input of 1. And see what is the other input. That is also 1. Clock also you are applying here. So 1, 1 you are applying here. What will be the output of this in NAND gate number 2? As you have applied 1, 1, the output will be now 0. So it means that from NAND gate number 1, you got the output of 1. From NAND gate number 2, you got the output of 0. Okay. Now what I told, in a NAND gate, if you apply 0, what will be the output here? By default, the output will be 1. Okay. So see, this one is coming back here. 1 and 1 you have applied to the NAND gate. What output you will get here? You will get the output of 0. And this 0 is coming back in this terminal. So 0 and 0, it means that you will get 1 here. Okay. So it means when you are applying S equal to 0, R equal to 1, Qn value is nothing but you are getting 0. Okay. And this thing is known as, you can write the comment. This thing is known as reset. Okay. So when you are applying S equal to 0, R equal to 1, your Qn value becomes 0. It means that this particular state is known as reset state. And in the remark I have written it is reset. Now come to the next state. Before that we can erase these things because so many things we have written here. Now come to the next state or next combination we can consider. So consider the case number 3. So S equal to 1, R equal to 0. Okay. Now as R equal to 0 means for gate number 2, NAND gate number 2, as one of the input is 0, by default it output will be 1. Now what about the NAND gate number 1? One of the input is 1. And what about the other input? That is also 1 because clock I told by default you need to consider as 1. So 1 and 1 means its output is becoming 0, 1. Okay. Now see for NAND gate number 3 what it is happening. One of the input is 0 as we have got 0 from the output of NAND gate number 1. So it means that that 0 is only applied to the input of NAND gate number 3. So as the input is 0, what output you will get? As I told is one of the input is 0, by default its output will be 1. So as it is 0, you are getting 1 in the output. And this 1 is coming back here. 1, 1 becomes 0. So what we have observed, if you have given the combination of 1, 0, we have got the output of 1. And this is known as set. Basically, I am writing this output as my output here in the truth table. I am considering the Qn value, whatever I am getting in this terminal, that is only I am writing here. I have not written any value of Qn bar. If I write here Qn bar value, it will be confusing. So in the output, you just have to write what output you are getting in the Qn terminal. After applying the clock, that will be considered as Qn plus 1. And that is only I am writing in the truth table. Okay. So you have found out the third node combination also. Now do the same thing for the fourth combination. But before that, let me erase those things. Okay. Now check the fourth combination. Now take 1, 1 means S equal to. Now consider S equal to 1, R equal to 1. So you see in this combination, what it is happening for the first NAND gate, one of the input is 1 and other input is also 1 because clock is 1. So 1, 1 means it is 0. And for the second NAND gate, this input is 1 and the other input is also 1. So 1, 1 means for the NAND gate, it will be 0. Okay. Now, if one of the input of the NAND gate is 0, what output you will get? You will get 1 only. So in NAND gate number 4, what output you are getting? 1. Why? Because one of the input is 0. Now see what it is happening for NAND gate number 3. In NAND gate number 3 also, one of the input is 0. If one of the input is 0, what output you will get? You will get the output of 1. Now in this combination, what you are seeing, when you are applying S equal to 1, R equal to 1, in this case, your Qn 1, Qn bar also becomes 1, which is not possible. One variable and its bar cannot have the same value. So it means that 1, 1 combination is not possible. Not possible in case of SR flip-flop. Okay. So these are the 4 different combinations we have applied for the input and we have found out what should be the Qn plus 1 value. Or after applying the clock, what will be the output that we have identified. Okay, thank you.